Okay, so this is the AP Stat Quideo number 4, and we're starting with the basic question. So as a summary of the background of the problem, it's basically the Census Bureau reports that households spend an average of 31% of their total spending on housing, and then there is a group of home builders in Cleveland that believe that the average is lower in their area. So your HO would be the 31%, and then the HA would be the less than 31%. Then they give you the population standard deviation, which is 9.6%. So starting with part A, it's asking what's the sampling distribution of the mean percent X bar that the sample spent on housing if the null hypothesis is true. Sketch a density curve. So what I did for this was, I checked the assumptions. So as you can see, NP equals 0.31 times 40 because 40 was the number of households surveyed, which equals 12.4, which is greater than or equal to 10. Then there's the QP, and that is 0.69 times 40 equals 27.6, which is also greater than or equal to 10. And then there's more than 400 households in the US. So they gave the average of 31%. So for the density curve, that's what's in the middle, and then defined the standard deviations. To find sigma, I did 9.6 over the square root of 40, and I got 1.52. So I did 3 standard deviations out, so I just added from 31, 1.52, then what I got from that, and so on and so forth. And then on the left side, I just did the opposite, so I subtracted the 1.52. And that is the sampling distribution density curve. So then moving on to part 4, it says suppose that the study finds X bar equals 30.2% for the 40 households in the sample. Mark it on my graph. Then supposing the mean is 27.6%, then mark it on my graph as well. And then why one result is good evidence that average Cleveland spending on housing is less than 31%, whereas the other result is not. So basically, when looking at, 30.2 is right here, and when you look at it, we can say that when the null hypothesis is true, there's still a fairly good amount of samples below the 30.2%, which is on that side. But when we look at the number of samples below the 0.6%, which is right about there, we can see that there's a smaller number, which means there's a lower probability of getting a mean that small, which does not provide as much evidence. And finally, for part C, it's just saying shade the area under the curve that gives the p-value for the result X bar equals 30.2%. So we're basically going back to the sampling distribution and shading anything that is below the 30.2, which is this section.